Today we will take some problems based on parallel plate capacitor. In the last class we have discussed about how to calculate the capacitance of a parallel plate capacitor with air or vacuum between the plates. If we let us recall those formula. Capacitance of a parallel plate capacitor with air or vacuum between the plates. Air or vacuum between the plates is given by C equal to epsilon naught A by D. And we know A is the area of the plate and D is the separation between the plates. A is the area of the plates and D is the separation between the plates. And this equation holds good when the space between the plates or the region between the plate is filled with air or vacuum. Now if we introduce some other dielectric, maybe a glass or paper. So if I introduce some dielectric between these plates with some dielectric constant K, then the value of capacitance changes and it is given by K epsilon naught A by D. When the space between the plates is filled with a dielectric, with the dielectric constant K, then C is equal to, we have to take into consideration of K also. C equal to K into epsilon naught A divided by D. These two cases we have studied. Now we will take problem based on this. Take down this. A parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. What will be the capacitance? What will be the capacitance if the distance between the plates is reduced by half? And the space between them is filled with a substance of dielectric constant 6. Read the question carefully. A parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. What will be the capacitance if the distance between the plates is reduced by half and the space between them is filled with a substance of dielectric constant 6? Now we can use the above formulae to calculate this. Given the capacitance C is equal to 8 picofarad, and this value holds good when the plate is filled with air. Let us say this capacitor has area of A and distance between the plates as D, and it is the dielectric is air. Now this is the first case, and in this case you are getting C is 8 picofarad. So it is the case when C is equal to epsilon naught A divided by D, which is equal to 8 picofarad, because air is filled between the plates. Now in the second case, the region between the plates is filled with a substance of dielectric constant 6, and the distance between the plates is reduced by half. So D has become now D by 2. The new D is D by 2 because it is reduced half, and area remains same, and it is filled with some dielectric with K equal to 6. Dielectric K equal to 6. So what is the new capacitance value? The capacitance with K equal to 6 and with the K equal to 6 and the distance between the plates is equal to D by 2 as the capacitance with K equal to 6 and the distance between the plates is equal to D by 2 as given by C dash is equal to K into epsilon naught A into D by 2. Substitute the values. K is 6. If I rewrite this equation, C dash becomes equal to 2K into epsilon naught A divided by D, and we know epsilon naught A by D is 8 picofarad. So substitute all these values. 2 into K is 6 into epsilon naught A by D, that is 8 picofarad. This is equal to it's 2 into 6 into 8, so it comes to 96 picofarad. So C dash is 96 picofarad. C dash is 96 picofarad. Therefore, the capacitance the capacitance value becomes equal to 96 picofarad. So the new value of C dash is equal to 96 picofarad. This is after filling the space between the plates with a dielectric of constant 6, and also the distance between the plates is reduced to half.